So, looking at a set of data, we have 3 students here that measured the mass of 5 aluminum bars, and they're each level, oh yes, 1 mole. Now there's a term that's coming back at us, the mole. All right, so I have a mole of aluminum for 5 of these bars. Now, here's group A's, group B's, and group C results after they've massed it, and I'm sure that they meant to have their units here be in grams. Now, if I want to find the true value for the mass of a mole of aluminum, where would I find that? Exactly, all right, I'd go to the periodic table. And when I did that, I found that a mass of aluminum should weigh 26.98 grams. That's to 4 sig figs from the periodic table. This is my true value. So that's what I will compare these students' results to. How would you describe the accuracy and precision from each group? Okay, there's my true value. What do you say about group A? Yeah, it's not precise. Excuse me, not accurate. See, there I go again. They're not accurate. Are they precise, though? Are they getting basically the same result over and over again? Yeah, pretty much so, all right? They're within a few tenths of a gram at least here and though, or here and there. So they would be precise. How about group B? What do you think looking at it? Huh? Yeah, they're kind of going all over the place. We've got 27, 26.9. That's not too far off. But there's a 25 and then up to a 28. So this would be, and are they all close to the 26? Not really. So this would be neither precise nor accurate. And then this group here, 26.9, that's close. That's, yeah, they're pretty close. They're just off by 0.02 of a gram there. So this would be both accurate and precise. Now they want us to propose explanations for the patterns that you see in the group. If you're getting the same results over and over again for group scale or for group A, they probably have a problem with the scale. All right, so their measuring device is bad. So incorrect measuring device. For group A. In group B, it's both the device and the readers. Now, you know, our scales can kind of drive you crazy because they will fluctuate quite a bit, even just with the air currents above them. So that's by reading the scale, you have to make sure that the environment is closed in. C doesn't seem to have a problem at all. So they're both accurate. Their measuring device is good, and so is the readability of it. Okay, just a couple more things here. Determine the percent error for groups A bar. Percent error, do you remember how to calculate percent error? Yeah, you take the observed minus the actual, divide it by the actual, and then to get a percent, you're going to divide or multiply by 100% there. All right, now the observed is the data that you get. The actual is they call it actual or accepted value. Whatever you want to refer to it as is fine there. We know the actual value. We can put that in easily because that's what you got from the periodic table. The observed value, I've taken an average of group A. And group A's average was 28 28.368 grams for their average value. And that's the only group that we're really dealing with here. So I added them all up and divided by 5, and I got 28.368 grams, and then minus the actual, which was 26.98 grams, divided by the actual 26.98 grams, times 100%, and the percent air came out to be 5.20, again to 3 sig figs percent. So I just leave it as a positive or a negative value. This tells me whether the result is over or under. Sometimes you'll see definitions for this where they use the absolute value symbol so that you always get a positive number. I actually like to see if the value is over or under the accepted value, so I just go ahead and leave it without the absolute value there. Percent deviation is probably something that you haven't dealt with before. It is really a way to determine precision with no set standard. And it's the actual minus the mean over the mean times 100% again to change it to a percent. So it's just a little bit different. While you see the values have changed here, many times you take several different measurements, so you would get the mean value and compare it with the actual value. The actual value here is 26.98 grams minus the mean value was 28.368 grams over 28.368 grams. And this would come out, when you change it to a percent, actually haven't calculated that, so I'll let you do that. But here's your basic formula for finding the percent deviation. All right, and we'll use this as we go through some of our more sophisticated labs. All right.